So the freedom of the particles to move around is reflected over here in the animals, which have the freedom to move around. That is what would distinguish the animal kingdom from the plant or vegetable kingdom, is that the animal has freedom of motion. The plant stays in one place, but it has its own kind of freedom. It has the freedom of growth. It multiplies this cellular tissue, cell division, by growing, also by storing order, as I said, against entropy. But growing and storing order are really the same thing. See, the tree has grown to an enormous stature, storing all this energy in wood. But it's also an ordering of molecules that made this energy available. So the storing of energy, which is growth, it's also, and this is a very useful word here, organization. The cellular principle of growth, is dependent on a very correct organizing principle. Each cell is like, well, much more complicated than the entire organization of General Motors. Just to digest one starch molecule takes something like 100 different processes per second, going on in hundreds of thousands of places in one cell. And each of you consists of something like trillions of cells. So the organization principle here, once accomplished, is then taken over by the animal, and a new principle is introduced. Now I bring in another thing. I said this was a recapitulation, but I'm gradually merging into new material. That the animal doesn't bother with making its own energy. It draws on the plant for that in the form of food. Whereas the plant is storing energy, the animal is using energy to attain goals. Chases that animal, or runs away from this animal, or finds a mate, or finds food. This is mobility. And it's directed at goals. It resembles the freedom here, and there's freedom of position. In much the same way, if I put a mouse on the floor and I came back 10 minutes later, he wouldn't still be there. He would have moved away. The same way the particle. You can't tell where it is. Now, where's the resemblance between this and this? Well, this one, which I just sneaked that in, atoms, because I was trying to spare you science. But remember, I said the concepts had a freedom of their generalities. The atoms have the freedom in that they store and release energy. An atom, you know, you've seen these spectrum lines. The spectrum lines are kind of music that's issued by the atom at its own characteristic frequency. But you cannot predict when it will do this. It comes completely either at random, if you want to say at random, or at the volition of the atom. You have no way to tell which. For my purposes, it's all right to say it's at random. But when you get over here, the plant is releasing or storing energy. You can't very well call it at random because it's very definitely keyed to the cycle of the seasons, to the night and day cycle, to what the requirements of the plant are. The plant is doing it in a controlled way, whereas this, we have to say, is a random, as far as we can tell, is a random way. Well, in a similar fashion, the motion of animals is a controlled motion, where this is a random motion. So you see, I've been able to describe the entities over here in terms of the same parameters as these, with the introduction of the term controlled as against random.